Interactive panoramic ray tracing for mixed 360 RGBD videos. In mixed reality applications, it is challenging to insert virtual objects into the real-world environment in a photorealistic way, because the lack of geometric information will cause inconsistent lighting, and real-time performance is difficult to guarantee. In this paper, we introduce an interactive panoramic ray tracing method for rendering photorealistic illumination and shadow effects in real time when inserting virtual objects into 360 degrees RGBD videos. Our method supports spatially varying global illumination for multiple virtual objects materials, including diffuse, glossy and specular, and allows both dynamic virtual objects and changing real-world geometry. In this chamber panorama scene, we insert two diffuse present boxes, a glossy bottle, a glossy hanger and a tissue box. When the hanger moves, the shadows on the wall changes accordingly. On the table, the reflections on the glossy bottle also changes when the bottle and the present boxes move. In this 360-degree RGBD panorama apartment scene, we compare the rendering results of our method and the IBL method. We inserted a virtual basketball, a hanger, into the scene. When the virtual ball is bumping, the shadows on the real ground and the reflected images on the foot of the hanger is also changing accordingly. In IBL method, there is no shadows and the appearance of the hanger stays still. On the table, the reflected images of the real jar and the virtual present boxes can be seen on the surface of the bottle, while IBL method renders incorrect and still reflections. We also synthesized 360 panorama RGBD videos with 3D models from fixed viewpoint. Then, we insert the virtual Utah teapot and the Stanford bunny into kitchen, one for diffuse and another for glossy material. The result images of our method are compared with images rendered by IBL method and the ground truth images, which are rendered with full geometry of the scenes and the objects using traditional path tracing method in Mitsuba. For the diffuse Utah teapot, our method simulates the shadows on the chopping board, and when the tomatoes approaches, the color bleeding on the teapot surface is clear. For the glossy Stanford bunny, we can clearly see the shadow on the table and the red pepper is reflected on the bunny surface. When the yellow pepper appears and the red pepper moves, the appearance of the bunny also changes coherently. Compared with IBL results, our results are more similar to the ground truth. To verify the effect of our back face-aware tracing method, we render two images in the synthetic scene kitchen with and without back face filling and compare them. Look at the inserted Stanford Lucy statue. Without our back face-aware tracing, the right half of the statue's feet is occluded from the window lights. However, our back face method detects the gap of the table's edge and finds the correct interactions with the window outside the user view, as the ground truth shows. Comparing the results, our back face-aware tracing method can simulate more realistic images of the inserted objects. In conclusion, we have presented a real-time rendering framework based on our interactive panoramic ray tracing method to facilitate photorealistic global illumination in MR for 360-degree RGBD video. The results showed that our method can produce photorealistic images over 100 fps. Our method can significantly improve users' sense of reality and presence.